Hi folks, so we are looking at slope to start off the new chapter, chapter 6, and chapter 6 is all covering linear relations. Okay. So in the last chapter, we did discuss rate of change a lot, and as a reminder, that meant our change in y divided by our change in x. So we would do this looking at tables of values, looking at ordered pairs, we did it looking at graphs. So what we're going to do now is instead of call it rate of change, we're actually going to call it slope because slope is what we use when we're discussing graphs. Okay? Rate of change is more a circumstance or a situation when we have variables that represent the change in y and change in x. Okay? So we are going to call it slope from now on. If you're in my French class, slope is written as pente. So we can say change in y and change of x, but another way to say that is the rise is going to be your change in y, and the run is going to be your change in x. Normally we write slope as m, okay? And then to figure out what the rise is, so how far we go from this y value to this y value, we could say this is x1, y1, and this is x2, y2. Okay. So to find this length here, it's going to be our second y value minus our first y value. And then to find that same run or the change in x, we're going to be looking at doing your second x value minus your first x value. Basically, when you're doing that, you're just finding the line segments here in green and in blue. So up until this point, we haven't used a formula. We've always been just reading or finding the change in tables of values, but this is the formula that you can use to always find the rate of change or the slope. So we're going to do one both ways. One, we're going to do reading the graph, and then one we'll do using that formula. Okay, so I'll rewrite it up here. So a reminder, we always would look at any nice points. It doesn't need to already be on the graph, but if it is, that's great. And we create a triangle. So we're trying to figure out how far we'd either have to go up or down to figure out our change in y. So up, we'd have to increase 1, 2, 3, 4, 5, 6. So positive 6. And now we're up here. We'd have to move this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Positive 10. And again, I'm getting positives because I'm moving towards the positive y values, and I'm having a positive here because I'm moving towards the positive x values. So my slope here is going to be 6 divided by 10, which if in this point you can reduce, you must reduce. So we'll get 3. Sorry, so I'm dividing each of these by 2, 3/5. In this one, let's use the different strategy. So I'm going to start by writing out these 2 points. So this is the point -3, 4, and this is the point 2, -6. So if I wanted to fill in this formula, maybe we'll say this is x1, y1, and x2, y2. So we can do -6 minus 4 and 2 minus -3. So we have -6 minus 4, that's -10. And then 2 minus -3, that gives me a +3. So over 5. And then -10 divided by 5 is -2. Okay, so the slope in this case means that for every 2 I decrease, I'm going to increase by 1. 2 over 1. So again, you can choose either of those strategies. Some people like the formula because it's a way that will consistently work. Some people are very apt to reading the graph, and that's totally okay as well. So let's see if we understand what the slope is really telling us. So this says, can we draw a line segment with the slope? Okay. So it's not saying anywhere we need to start. So I'm giving you the go-ahead that you can start wherever you'd like. So for A, I'm going to do this in blue. Maybe I'll start right here at the center. So a reminder that the 7 on top here is our change in y, or what we would write down as our rise. And this bottom number is our change in x, or our run. Okay? So we're going to be rising up 7. So I'll go 1, 2, 3, 4, 5, 6, 7. Okay? But then I'm running 5 towards the positive. So 1, 2, 3, 4, 5. So at that point, this would be the next point. So now I'm going to draw a line, but I'm going to use a line setting in here. If I can open it up. So let's see. That will do. Because again, remember when we're talking about slope or rate of change, if we're saying it is consistent, then it is linear, which means we can make a line through it. Okay? So this would be the first A line. Okay? Now how about if we do B? So since you see -3/8, that negative could either apply to the 3 or it could apply to the 8. Okay? It cannot apply to both because if you had -3 divided by -8, you would have had a positive overall. So let's just do this one here. So maybe I'll start over here this time, just to be a little out of the way. So I'm going to rise 3 and then run -8. So I'm going to go up 1, 2, 3, and then I'm going to go backwards 8. So 1, 2, 3, 4, 5, 6, 7, 8. And that was my fault for going off the graph, but that's okay. We will survive. So our line is going to look like this. Okay, so next one, let's try it out. So determine the slope of the line that passes through these 2 points. So at this one here, what's interesting is we have no graph. Okay? And that's what we're going to end up starting to move towards is what if I just give you data and can you find the information needed to either find the slope or find the equation of a line? Okay? So I am going to rewrite that formula so you find the difference in the y's and you find the difference in the x's. And this is in the formula booklet. So again, for either of these points, you can either name this one x1, y1, or x2, y2. You could name this one x2, y2, but remember the 1's stick together and the 2's stick together. So if I were to fill in this formula, I'm going to take the two y values, so it's going to become 1 minus -3, and the x value, so 2 minus -5, which is going to give me 1 plus 3, so 4, and 2 plus 5, which is 7. So the slope in this case would be 4/7. And then the last one here. So we're looking at some data that Yvonne collected on a cycling trip from from North Winnipeg to Grand Beach. Okay. So what is the slope of this? And then we're going to have to figure out what it represents. So again, in this case, we could call it slope. We could call it rate of change actually because there is values on the x and y axis. And although there isn't a line here, there easily could be a line. This could be continuous data because both time and distance exist. Okay. So I will make that line there just so that we understand that we are trying to find the slope. Okay. So again, you can either read the graph or you can find the 2 points here and fill in the formula. But I am going to read the graph just to keep practicing different methods. So we'll go rise divided by run. So let's look. If I start at this point, I rise up towards the positives 24. And then again, I'm up here now and I run over 1. But in this case, because there are units, I should include them. So it's 24 kilometers in 1 hour. And what does this represent? It represents the speed of Yvonne's cycling trip. So now let's do this. Part B kind of looks like what we were doing in chapter 5. So how far has Yvonne traveled in 1 3/4 hours? So here's 1 hour, here's 2 hours, here's half. So 3/4 is going to be around here. So I'm going to move up to the graph. Okay. We could say that's probably somewhere around 36 to 48. So there's a 12 difference here. So it's probably about in the middle. So about 6 up from here. So maybe about 42 kilometers approximately. Okay. And then the time it took Yvonne to travel 55 kilometers. I'll try to use a different color so that we're not messing it up. So let's look at 55 Well, here again, it's going up by 12. So in the middle here would be 54. It's a little bit higher than that. And I'll have to go down and approximate where this is. About 2¼ hours. So that's slope. So at this point, I would definitely suggest try out the little quiz and try out a couple of the questions that I have inserted in this webpage below. Good luck. Send me an email if you have any questions.